All right. So this is part two of our Git workshop. This one, as you can see, focuses on really the collaboration aspects of working with Git and GitHub. Specifically, we're going to talk about an approach called the feature branch workflow. There's a couple different workflows you can use with Git and GitHub and branches. Um, this one has been around for a long time. It's popular. There's one or two others that maybe are a bit newer, maybe a bit better in some ways, but it's sort of a classic, for lack of a better term, and it's a really solid starting point. So that's what we're going to focus on, and it should be pretty familiar. This repo, by the way, is a separate one, but it's in the Code Platoon curriculum GitHub org. And if you go to the main org page, there's a README. And if you look down under workshops, you'll see that there. And that also has the part one that we did a couple weeks ago. So why are we doing this? I know I've said this a bunch of times, but software development is a team sport. Really, I think you all are getting to the best part of it now on the group projects. And Git and GitHub and these workflows are just the common practices and the common language of software development. Google actually famously uses a different kind of version control that I think they might have built themselves as they build a lot themselves. Microsoft might not use Git. I'm not sure, to be honest. There were some different kinds of version control out there before Git, but Git really has become the standard and is standard knowledge in a lot of ways. And it's not just about the mechanics, it's also about like certain well-known practices of how teams like work together and collaborate. So today's workshop is kind of like a blend of these things so that you guys can collaborate effectively, not lose code, and most importantly, when you go into the interview process, um, there's a good chance you might be asked about these things or in some way assessed, but also you should look for opportunities to talk about this stuff. And some of the things we're going to look at today with pull requests and code reviews are actually things that can add to the portfolio value of your group project. Because there's a big difference between like saying, hey, check out my group project and all right, the code is fine, the code is great, whatever. And hey, check out my group project, and there's like a rich history of GitHub issues and pull requests with really good like discussions and descriptions and stuff. Whenever I work with a new repo or I'm evaluating a new repo to use, the first thing I look at is GitHub issues and pull requests to figure out if the repo is dead or not, especially with JavaScript React stuff because it changes so fast. Like I need to figure out, is this like library still maintained, right? So the more you do this, the more you start looking at those GitHub issues and pull requests. And so there's a lot of value to that for your portfolio. So the first part is going to be going over the feature branch workflow. It's pretty familiar to you guys, but we're going to review it. We're going to do a little bit of a demo. I'm going to talk a little bit about pull requests and code reviews. We're going to do a little bit of a demo for that as well. Um, I'm going to ask for a volunteer, in fact, to write a little code, but it's going to be really straightforward. Um, then let's see, this part two, I apologize, is actually condensed into part one. So just ignore part two. I'll talk a bit about merge conflicts, what causes them, and we'll demo creating some merge conflicts, some simple ones, and how to fix them in VS Code using, I think they call it the merge tool or a diff tool, as in the difference, looking at the difference between things. And then I have a team exercise for you all to do in teams where you are going to, I've given you all code to build a Pokédex that we're familiar with from class, Django and React, but it's sliced up really fine so that each person is going to have to do a tiny bit of code on a feature branch and make a pull request and have that code reviewed and merged. And it's going to force you all to communicate and collaborate and think about how to sequence your work. Um, then really what this all leads up to is some like guidelines and best practices for team productivity and sort of the golden rules of of Git when you're collaborating. And this is the stuff that will help you avoid merge conflicts and be more productive. And that's really like the secret behind merge conflicts is the best thing is avoiding them. Um, so I know you all are familiar with some of this, but we're going to go over creating feature branches, writing code using this workflow. What's a good pull request? What's a good code review? Getting comfortable with this process. We'll see how to safely resolve basic merge conflicts and how to plan work. And most critically, um, you all will be able to understand and explain to others why we do this stuff and why it matters. Any questions before we dive in? And out of curiosity, how many folks like when I've said like feature branch workflow, I think like 10 times, and I'll be saying it a lot today, but how many folks are already familiar with that? Owen, James, um, Juan, I see a couple other hands. Um, Juan, do you maybe want to describe just in a nutshell what it is?
The feature branch,
Uh, yeah,
the feature branch
the
workflow.
yeah, yes, sir.
I mean, it's if I'm understanding it correctly, it's pretty much like to give an example. I actually just sent this to Ryan. If he's checking out and making a brand new branch, the way that my team is starting to do it is feature forward slash game app. So it's describing what type of branch is being made and for what purpose. In this case, it's making a feature, and then the name of the feature, like a brief description, I guess you could say, so people
Hmm.
know what it is. Or
Hmm.
you could even put as an example so they know it's uh, bug fix forward
Yep.
slash login. What was the example I use? Like login issue with logout, something like that. So people know it's like, okay, at a glance, if I need to go back for whatever reason, this is properly titled for everybody to be able to see.
Yeah. Exactly. Exactly. And what's the reason for doing this? Beyond the points you made of like well titled and having the branch names and stuff, like why are we making separate branches instead of just doing this work on the main branch?
Just to avoid any issues with merging conflicts, especially if someone's working. We're actually going through a merge conflict right now that we're learning through. Uh,
Ah,
Being able to fix these kind of issues before putting it onto the main branch and completely breaking the app. So this way
yeah,
it all gets filtered from the branches that you check out and make to the dev branch. And then from the dev branch, if everything works well in testing, you could push it to the main branch, which is production code itself.
yeah, exactly. Exactly. You hit the nail on the head. Um, yeah, and I'll talk a bit about a production branch and if we want or need it. The main focus of today is really on like feature branches and main. And you touched on what is like 1000% there where there's really two golden rules. The golden rule, uh, so as you guys are probably learning, uh, two people shouldn't touch the same code at the same time and protect the main branch. I'm going to go over these sort of in the culminating lecture, talking about the kind of teamwork collaboration practices. Um, but I think the first one is pretty intuitive. We'll see an example of it when we cause some merge conflicts. But basically, a merge conflict is caused when two people touch the same code, commit it, and then both, are trying to merge those changes, however it's happening, whether it's onto main or I'm pulling main onto my feature branch. And Git does a good job of not being too smart. It doesn't try to figure out the right version of the code. It just tells us there's a conflict. Um, so the more you can sequence work, the more you can organize work, the more you can organize your code. This is why like having one React component per file, one Django model per file is often considered a good practice because it means that stuff is in separate files, which means that it's easier to work on different Django models in parallel without touching the same file, right? Which reduces the risk of a merge conflict. There's other reasons as well, but that is one. And then there's this other one, protect the main branch. And this one is actually really, really important. Um, I'll talk about this more at the end, but now that you all are working on group projects, anyone at any time should be able to pull down the main branch and run it, and it should work. Let me just say that one more time. Anyone at any time should be able to pull down the main branch, look at its README, see all the steps they need to do to install and run the code, and run it. It never, ever, 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 ever should not work. Right. And that's a little different than the way that we've written code thus far, I would imagine. Because I know for me over the years, I've written so much code where my code was not in a good state like three-fourths of the time, because that's just part of the process of learning. Um, but this is a switch where the code on the main branch should always be in a good state. And it might take a bit of extra work, but you'll find if you do this, it forces all sorts of habits that help you both kind of as an individual programmer and as a team be more effective. So let me check in first of all and ask like how many groups are already doing this in terms of how they work and with the main branch. And like if I went to your repo right now, I could clone it. The README has all the instructions I need and I could run it and it would work. How many people have tested this to see if it works? Right? And that's okay. Um, and when you join an engineering team, this will very much be how it is. Because if you think about if you're on a team of, well, first of all, teams of 20 don't really exist the way you think they do. Um, like there might, like they usually get broken up. There's a saying like it shouldn't take more than one or two pizzas to feed a team. Um, 6 or 7 starts to get big for a software team. And what starts to happen is, 20 people might be broken into 2 or 3 teams, and they're rather than all working on one big code base. Google famously has one giant code base for everything, which is an approach called a mono repo, where you have everything inside a repo. But Google does stuff a little different. You'll have separate repos with basically separate applications, or maybe like rules and conventions. But as the project gets bigger, as the team gets bigger, this becomes more important. So this can cause a little pain up front, I know, but if you all take time today to make this switch, so that by the end of today, you guys have confirmed that the main branch runs, it works, and there's instructions for it, and we keep that README updated, and you maintain that as you work on the project, you'll find that it actually lets you be more efficient and move faster. Um, do folks have questions or curious about anything I've been talking about, whether it's like why this matters or like, hey, if that seems a lot of work or seems straightforward or anything on people's minds? Jacob, yes, sir.
Yeah, as far as branching goes, so like, uh, I'm guessing I'm looking towards like the end of like a project's like, you know, being basically functional. Um, Once we have all of our code merged into the main branch from the different diverting branches, what do we do anything with the branches that we kind of branched out with, or do we just kind of leave them there, or like what's the process for that?
Yeah, great question. You can just leave them there. You can also, once you use the pull request to merge a branch to main, you can delete that branch if you want, because that code is now on main. Some teams like to delete the branches to keep too many branches from accumulating.
Yeah.
Other teams might not care as much. Um, but the third golden rule related to this, and I'm going to go over these again later, but we're getting a preview, is never touch another person's branch without permission. Because, you know, I might have merged my feature branch to main for the user info API endpoint that I was working on. but I might want to do more work that I'm writing on that feature branch. I might be doing something else. Um, you know, so there's really like an ownership there. Like, and then so it's my job to delete the branch or tell someone else that it's okay to delete, but you don't want to go around deleting other people's branches. That's a bad idea, right? Because then all of a sudden we're destroying the whole value of Git and GitHub, which is like having this record and this history and this different versions of things. Does that make sense? Cool. Um, so as you can see, there's a lot of sort of like we'll see there's some rules you can configure as well in GitHub to enforce some of this, but a lot of this kind of depends on people following the rules. Basically, the same way that we all know red means stop at a stoplight, yellow means slow down, green means go, and the rules around who gets the right of way at a stop sign. Um, it's the same thing with software development, and where communication is key. So I'm gonna do a little more talking and then we're gonna demo this. But just to sort of like walk through what I've written out here, um, let me pull up our annotator. This is the basic workflow of of this feature branch workflow. First thing I'm gonna do is actually pull down the most recent version of main. First thing I'm gonna do is pull down the most recent version of main. Then I'm going to create a branch off of main, and I need to pull down main to make sure that I have changes that anyone else might have just merged. Then I can do my work. And as I work on this, I should actually be pulling down main and merging it into my feature branch at least once a day, which I'll talk about later. Then I should be pushing code as I go, as you all know. There's zero downside to pushing up my feature branch on GitHub. And then I create a pull request. And creating a pull request is perfectly safe. It doesn't actually merge anything. Then once the pull request is approved and reviewed, it gets merged. And it's the actual merge command that then adds these commits onto the main branch, right? And then my task is complete. So let me walk through this just a bit, and then we'll demo it and write some code. So this is the basic workflow, and this might be useful to have like written down on a post-it note somewhere. You pull down main, you create your feature branch, um, you're going to write your code and push it up. Then you make a pull request and you update main on the feature branch and approve the pull request and merge it. Um, so let me go ahead and just demo this process. Oh, and yes, sir.
Before you get into that, so
Yes.
say you have a feature branch, main is at like probably say several commits ahead of you. Can you can't really pull from main if you've made a bunch of commits on that branch, correct? Because then it would if you merge main, then all that work would be gone, correct?
Great question. You can, as long as you've committed the. Actually, you can in a number of situations, and you won't lose the work.
So by like I have an example with our project. We updated the settings.py. I've been working with a whole
Mhm,
different part of the project.
mhm.
I want to pull the settings PY from the main, those commits onto my feature branch. How would I go about doing that? Even though my feature branch is like 11 commits ahead of the main
Right,
branch.
right. I think the easiest way to show that is to demo it. Uh, and we'll do that in just a minute. The short
Gotcha.
answer to your question is, and in fact, um, I can demo this
If you want to
Uh,
wait till later in the lecture to demo it, that's fine, because then I'll get my answer then. That's
yeah, we're in fact, you know what? Oh, and if I can, yeah, I might draft you in to help on this.
okay.
Yeah, the short answer is what I absolutely can do is if I'm over here, and this is, let me just quickly orient you guys to the repo. Um, so let me, I need to add some code in here. But like let's pretend here. There's nothing here, but let's pretend I've just pulled down main because I haven't actually added this code onto the GitHub. And is this font size okay for everyone, by the way? Cool. So let's pretend I've done a bunch of work here. I have a bunch of commits. Well, I can run git merge main, and what this does is it takes the version of main on my machine and merges it onto my feature branch, all on my local machine. Now, what happens next, Owen, depends on the code itself. If there are no conflicts, this will probably work fine. Um, if there are the same bits of code that have been changed, then you will indeed see a merge conflict. I don't think doing this overwrites any uncommitted code you have. I'm like 90% sure. But just in general, before I do this, I try to make sure that everything on my feature branch is committed. Or if I have work in progress code, what I often do is, and let's just maybe add a method here just to show this. So if I use git diff to see the difference between the most recent commit and my working tree, the code in there, we see this method that I've written that hasn't been added or committed yet. And now I've got that there. And let's say I'm working on something and it's still in progress and I want to merge in main. Well, there's a very nifty feature called git stash, and it literally just takes any uncommitted code, any code in the working tree, and sticks it away, actually in a stack data structure somewhere else in that .git directory. And this is super useful because now I have a nice clean branch. Main doesn't have any different changes, but I would merge it, and then I could do git stash pop and bring back that code that I just stashed. So that's one nice thing to note that I do all the time. Um, but let's go ahead and let me just add this code to the the this repo so we can go through this process. And I do have a little bit of setup to do here because this is an empty repo at the moment. Um, and I'm going to run this command to push the existing repository to it. So let me actually take care of this right now. This part you guys don't have to worry about. This is just me doing a bit of setup. Oh, the local changes. And in fact, this is giving me some nice branch protection rules. Because if I check out main, something gets overridden by some change I made. So let's just get rid of that goodbye method. Remote origin already exists. Oh, well, that's good. Um, I think I may have just made this before and never pushed anything to it. Let's see if we have our code here now. There we go. So perfect. We've got the code. Um, I think most of you already did this in setting up your repos, but just to show, we're going to add some access, which I need to do also because by default, none of you have like write permission on repos in the curriculum repo. So we're going to add, you all would be doing this with individuals. I've set up some teams to help manage things. So we're going to add you all as contributors, and let me add the TAs as well, just so that they're there. You guys don't really need to worry about GitHub Teams. There's a lot of companies don't necessarily use it, and there's no value to it for you guys for teams this small. But so now you all should have permissions on this to go ahead and do stuff. And in fact, let me dump this link in there. And Owen, if you don't mind, I think I might draft you to help with this. But if everyone
No,
else also wants to just clone this down as well, that would be great, just so you have it. And so if if you have the desire, you want to try it out, we can kind of do some of this together. And what I'm going to do is I think I'm just going to show like the whole flow of me making a branch and adding a feature, sort of using the feature branch workflow. And Owen, then you can like review and approve the pull request, and and then maybe we'll cause some merge conflicts. Sound good to folks? Cool. And does anyone have any questions or things you're curious about? Okay, awesome. So again, our code here is pretty darn simple. It's a Flask app. There's a couple students. There's a ping. There's a get students endpoint. Um, and that's really all there is. Um, I think what I'm gonna do is show the whole flow from like even making a GitHub issue. Where I would write it out. This is where you could actually put a full spec in there. Um, and this is also where you can start to specify things like maybe we want a standard message format. And where issues can really start to become good documentation as well. Let me get rid of my annotator. And what I wanted to make the issue because it does a couple things for us. First of all, it forces me to spell things correctly. Second of all, we're going to be able to tie the issue to the pull request. And third of all, a really good convention to follow is using the issue number in your branch name. So if I'm working on this and I'm working on this feature, first thing I'm going to do is pull down main to make sure I have the most recent version of main. It looks like I have a typo here. I'm not sure how I messed that up. I'm going to make sure my working branch is clean. It looks like, in fact, there's a bug here on main. So we can actually, if we're being really strict about following the feature branch workflow, what I would actually do is this. I didn't do this on purpose, but this is actually great to see. Um, Fix typo error in app py. And I would just say like uh, breaking error in app py. And I don't really need to add more than this because the pull request itself will serve as documentation. But if our team is big enough, we might be using labels, and you can create labels as well. If you want for prioritization, could be a good set of labels to create. Um, and it's a good habit, I think. Or front end versus back end, that's a good label as well. Um, so I'm switching gears. I'm going to fix my bug, and I'm going to do git checkout dash B to create a new branch. And let me go ahead and clear this. And I'm going to start the branch name with the issue number, and then a very brief description in the branch itself. And this is a pretty good way of naming branches as a naming convention. You'll see a bunch of different approaches. This is a simple one and it's effective. Let me go ahead and fix my typo. Use git diff to make sure it looks the way it should. In fact, you know what, guys? I think my typo was me maybe accidentally copying a line because I have two of the same people here. Let's just pretend this was a real bug. And we'll throw in, we have Harry Potter names and then some normal names. So we'll just throw in another Harry Potter name.
Use the same ID on line 26 and 27.
Oh, thank you. Um, I'm not gonna worry about that now because that's yeah, let's actually fix that too. That's actually Demi, thank you. And actually this will let us demo something useful. Um, so first off, I'm actually gonna make these fixes in two separate commits so that each commit addresses an individual issue. And it looks like, oh, did I not add my changes? Okay. They're just going to be there as one for the purposes of simplicity. We'll fix imaginary bug, fix bad ID vals. And I haven't created this branch. This branch doesn't exist on GitHub yet, so we need to push it upstream to GitHub, which is our origin. And there's a link here that I could copy and paste in to create a pull request. What I always just end up doing is if you go to the repo, you'll see GitHub says, hey, there was just a push here. Should I create a pull request for it? You absolutely can push this button to do this. You can do it here as well. Let me guys show you the manual process just because sometimes you need to do this and it's useful to see. So the base is the branch we're merging onto. Compare or target is the branch we're merging from. We're bringing the changes from main, well, that's what we need to fix, from my feature branch to fix typo onto the main branch, right? And the nice thing about that automated create pull request button is it sets this stuff up for you so you don't have to do it manually every time. In practice, I just hit the button that GitHub gives you, but I wanted to show you guys how to do this. Because every now and then you need to manually tweak these because you're doing something a little different. Remember, making a pull request is always safe. It merges nothing. So don't be afraid to make pull requests. You're not going to break anything. Here we can see the changes. We get a bit of a preview. Let's just go ahead and make this pull request. Now, let's talk about what should go in this pull request message. And I am going to jump over here to the lesson because I have a long, long list of what should go in a good pull request message. This seems like a lot of stuff, but it's actually not. And we're going to look at a couple examples. So first off, the code's got to run. Once the pull request is ready for review, it's got to run, it passes all the tests. And if the pull request isn't ready for review, you probably shouldn't make a pull request yet because you've got the feature branch. It has no errors. Merge conflicts are fixed. The title's meaningful. A link to the GitHub issue, which we're about to add, or a Trello card if you're using Trello. A description of what the PR does, showing relevant code, instructions for reviewers on how to run the code. Because in theory, a good code review, you should actually be running the code as a QA step. So if I created a migration, I would note that in the PR to tell people, hey, you need make sure to run the migration command, run, Python manage py migrate. Especially for UI stuff, a screenshot or even a video sometimes, diagrams, and then you add relevant people for review and tag other people that are needed. Because maybe Owen owns app py, so I need to make sure that he's the reviewer for this. And this might sound like a lot, but let's look at some real world examples. Here's one from the React project where they did some DevTools stuff. And you can see, in fact, that this person added a video demoing the feature that they added to the React DevTools Chrome extension. Which, if you think about how someone else is going to meaningfully review a UI feature like that, this makes a lot of sense. The PR description is meaningful. There's a nice plain language summary. They explained how to test it. That's also a good thing. I should have mentioned that explicitly. There you have to change something in the settings here to test it. How did you test it? If you look at every single pull request on the React code base, you'll see that Facebook requires you to add this. And then here's a link to the issue that it addresses, right? In this case, it's fixing a bug. Over here on the Django open source repo for the Django framework that we've been using, we can see the same thing. Django has a ticket. They have some sort of ticketing system that they use. They're not using GitHub issues. But you can see here how rich this description is in terms of what the task should be, right? And you all can and should do this. And this becomes part of your portfolio, having it in GitHub issues or a public Trello board that you link to from the repo. A description of what's happening. This one actually has a nice little checklist of what it does. We'll talk more about the review and all the discussion that happens later, but I just want to point out that that list I made seems kind of long, but both those things satisfy all these conditions and don't do, too much work. So let me go ahead and add this to our pull request. And actually, while I'm doing this, do folks have any questions? So what did we do here? We fixed the typo bug in @py. We fixed incorrect ID values. We fixed username. And the great thing that GitHub built into the UI is if I just do the #, it gives me a list of all the issues and I can just type 2. And GitHub will make that link automatically. And there's no extra steps needed to run or test. Tested by running code. So I'm going to create my pull request. Nothing's been merged. I'm going to add a reviewer. So I'll add you here. And just for fun and to demo it, I can use the @ symbol. And Demi, what's your GitHub username?
I'm not even sure off the top. Let me see.
Is that your first and last name?
Yeah,
That's what
first
I
name.
was.
Yeah, Hakan. Yeah.
Thank you.
Okay. Mhm.
And just to demo how you can tag other people, and now up here in the little messages, Demi and Owen, you would each get a notification. I think you both might get an email as well, depending on how it's configured. You guys can also connect GitHub to Slack. So you would get messages maybe in a team channel and also individually when this happens. And people can have a conversation down here. And then what I would do is I would dump the link to the PR message in my team Slack channel and say, hey, this is ready for review and merge. You know, Owen, can you review it? Or if I don't need someone specific, just say, hey, can someone review this? Um, and Owen, if it is a good moment for you, if you maybe want to share your screen and just like, I know that this is pretty straightforward, but you can just show us adding
Yeah.
whatever comment you want and hitting the approve button. Um, and actually, before you do, this raises a good point. The general rule is the person who created the pull request should merge it. So your job is to approve it, Owen, but it's still my job to merge it. And the reason here is, again, ownership, because the idea is I'm the person who has the most knowledge of this feature and this bug. Maybe there's an extra step we need to deal with when pushing this bug fix to production. Um, so
So
it
I'll go
feels like an
back.
extra step. Yeah, this looks great. Add any comments you want and go ahead and ask any questions you have. And then you should be able to do a review. Yeah, so you can, yeah, if you want to, you can hit that little plus to like add a question or comment on a line of code. Um, when you're reviewing code, anything you're not sure about, you should ask, either to learn and understand it so you can more effectively work on this. And because the reason we do code reviews is because we're human, we make mistakes. This is a lot of code. Typos, bugs, simple things happen all the time. We want a second set of eyes. Code review is also when we can discuss design trade-offs. Like, why did you do it this way? Can you explain it to me? And half the time someone might said, I did it because I ran into issue XYZ because they're, deep in that particular issue. And I'll be like, that makes sense. Thank you for explaining. I didn't know about it. If I'm mentoring a junior engineer, I might say, cool, but actually, if you do it this way, it resolves this problem and gives us this advantage. So code review is actually where a huge amount of mentoring and knowledge sharing can happen as well. And then when you're done, I think you should be able to, I think just hit review changes. Um, you can approve. If you're not ready to approve, you can do request changes. The classic response is looks good to me or LGTM. You'll see a whole lot of that in the real world. I'll do that a lot, but that doesn't mean I didn't look at the code. It just means there's not a lot to say. Um, so this code review step is actually super valuable for you guys as a team. Um, a bug fix less so, but Demi, if you've added a new React UI component, that's useful for the whole team to know about, even if they don't have to directly work with it. Right. And so this is where this whole flow, not committing directly to main, making the feature branch, sharing the pull requests in Slack, having a chance for people to look at the code helps the team move forward because everyone gets caught up. Now, you don't need everyone on the team to code review and approve. In general, you really only need one, maybe two other people. But sharing the pull requests in the Slack channel, or even better, using the GitHub Slack integration to automatically do it for you, helps keep the team in the loop. And now if I go over here, oh, I love it. Thank you for the rocket ship, Demi. Owens approved it. Changes approved. We'll talk about rule sets in just a minute, where you can ignore that. And now I can go ahead and hit merge. And this is going to do on GitHub the exact same thing as if here on my local machine. If I was on the main branch and I did git merge this, I'm not going to run this. This is exactly what we're about to do, but just on the cloud, right? And to go back to our diagram briefly, we're now on this step here, right? The PR has been approved. It's the actual merge command that will now add this code to main. It's going to ask for a confirmation. It's always a good idea to double check. There's two really useful things you get in a pull request that in the GitHub UI, you can see all the commits. You can look at them individually. You can, in fact, use this nice little navigation to go through each commit. So if you organize your code in meaningful commits, it makes review easy. And most importantly, files changed. And you can see here what's called the diff, as in the difference between one version and the other. And this is important because this is similar to the tool we're going to use to fix merge conflicts that also shows a diff. And we see here on the right, the code from my branch that's getting merged onto the code on the left, which is the main branch. And the stuff in red gets replaced by the stuff in green. And we can see there's no merge conflicts here. It can figure out how to do this and make these changes. This is the most important thing to look at when reviewing a pull request on a practical level is look over the diff, make sure it looks good, make sure nothing is being changed that shouldn't be. Always do that kind of final double check before merging. And then go ahead and confirm the merge. The pull request is closed. We see merged now here. Our bug is fixed. And as to your point earlier, Jacob, there's an option over here to delete the branch. You guys are more than welcome to do this. You will still have the pull request and the diff. You'll still have the branch locally. This is probably a good habit to keep stuff organized. I would probably click delete branch. If for whatever reason we don't do it then and we need to do it later, and I'm not sure why, I apologize. I'm not sure what's causing that little pop-up over there right now. Just to demo another way of deleting branches, if you go here and you click on this branch icon or you click view all branches, you can see all the different branches. You should never be deleting a branch that doesn't belong to you without asking for permission. You can see over here, this branch is done. If I look at the pull request, it's been approved. It should be merged. I'm not sure why it's listed as an active branch, to be totally honest. I feel like it shouldn't be. But main thing is, like before deleting the branch, make sure that it's been merged. And now I can go ahead and I can delete the branch. I guess you can do more stuff over here, but we'll go ahead and we'll delete that branch, right? And so this is basically the feature branch workflow. Now there's one final step here. If you all remember, before I saw this bug that we wanted to fix, I had talked about working on a new feature, right? And if we go back over here to the issues, And in fact, I should probably assign this issue to myself so I can keep track of what I'm doing. We wanted to create this goodbye endpoint. So I do the same flow, except main has changed now, right? And this is where the team communication collaboration element comes into play. Like everyone else on the team, once someone has merged to main, it's probably a good idea to pull down the most recent main and if you can merge it onto your feature branch. So I still need to pull down main to get the work I did, right? If we go back to this TL draw, the flow is a loop for a reason. Even though I did all the work over here, I don't merge to main on my local. I do it up here so that the main branch for the team is in a good state. So I still have to pull down that new version of main onto my machine. So now I have that on my machine, and then I can branch off it again, right? And that's kind of the key piece here. And that's why this flow sort of feels like it has an extra step. It's because there's 5 people doing this all at the same time. And if you do it this way, you can keep it organized and avoid conflicts and issues. So let me just check in and see what questions people have or what's on people's minds. Is everyone feeling pretty good about this? Does this make sense?
Yeah, and
Cool.
I just found another feature too that was pretty helpful. I don't know if you're gonna cover it or not, but it's just like the page on GitHub where you can actually compare the branches and it shows, unless you already showed that, like where you can compare the branches and it shows if it's able to merge based on the 2 branches you choose. I felt that was pretty helpful. So I can see the
Yeah.
difference between like mine and Sean's branch on the back end and then compare mine to the main branch, or not the main branch, but the branch for the back end because we're branching off the back end branch. But yeah, so that's pretty helpful too.
Yeah. You'll see that the pull request itself has that with the file difference. GitHub will also like show you in very bright flashing messages if there's a merge conflict. I'm guessing is this over here where you like create a pull request and you get to choose the 2 branches and
Yeah, it's
slide?
a lot like that. It's you can, I think the URL is yeah, it's like um the owner and then the repo name and then slash compare and then it shows all the branches in the project. And then you can choose the two to compare there too. So it's very similar to like what this
Yeah.
is. Yeah.
Same same thing, in fact.
Yeah.
The UI makes it look a little different. Yeah,
Yeah.
totally. Yeah. And often sometimes I'll make a pull request just to look at the diff. And in fact, you can make a draft pull request. And in fact, let me show that now. And let me go ahead and show you guys some features. Have any of you messed around with adding like branch protection rules or rule sets? A little bit?
A little bit in our team, but it was messy. We
Yeah,
deleted them because it
I
was
tried it
messing with
too.
us too bad.
It was too
Yeah.
much.
Yeah, it can be a bit much. I agree. The one plus is it will kind of force you to do things a certain way, which I think can be valuable, but the whole team has to buy in on it. So there's really 3 things. Um, and again, these might add a bit of pain, but you kind of have to buy into the whole workflow. Like if you guys decide to buy into the whole feature branch workflow with pull requests and never merging directly to main, these rules become less painful. And basically, it's a rule so that you can't commit directly to main even if you want to. A rule that requires at least one approval for pull requests. And we're not going to cover this today, but the stuff we use for the automated tests for the assessments actually uses something called GitHub Actions, which is what's called a continuous integration tool, so that if you want to, you all could set it up so that whenever you make a pull request, it runs an automated test suite, maybe a linter to check for syntax and typo errors, and you can't even like merge the pull request until it passes all the tests. So that and all of these are completely normal on pretty much every software engineering team out there if they have good practices. Um, so this one we won't see. these two can be a bit painful. If you guys, I would recommend it, but again, the whole team has to be on board and you guys kind of have to buy into the whole workflow. Because if you don't use the workflow, these absolutely will be pain points and slow you down. So if you're not certain, you may not want to do it. You can add them one at a time though. Let me just show and demo these so you guys see what they are and how to use them. So the simplest one is a branch protection rule. And in fact, you can see that GitHub adds some nice helpers here. Let's just call this protect main. We'll say active. I think you all can do this. I'm not sure if GitHub requires you to be on the enterprise account, to be totally honest. Main is what's called the default branch on the repo. And what we're going to do is require a pull request before merging. So this is the one to do. Require a pull request before merging. All this other stuff does more complex versions of that. Like super admins, I think, can push directly to main if you do this. This is the simplest and easiest one. And now requiring approvals, this can be a pain and slow you down. So you may not want to do it. A lot of places I've worked at don't. And, as a junior engineer, they didn't have these rules, but if I didn't follow the way I was supposed to do it, I would have been told. I would have heard about it really quick. So a lot of these rules are not always enforced like in the code, they're enforced by practice on the team. As teams get bigger, you kind of need these. So it's not the worst idea to think about a minimum of requiring one approval. As you can see, you can get really granular, require a conversation before merge. Actually, this touches on something that we haven't really talked about, which is GitHub Copilot. If you all want to use Copilot for the group projects, I think you're at a point where that's okay. Copilot is also now free for everyone using GitHub or VS Code, I think, which is a major change. I actually don't know how to have Copilot do a pull request review, but that's actually kind of a cool thing that it can do it. I'll poke around with that. If someone wants to look at that, I think that'd be good. And you don't really want to touch any of this other stuff. As you can see, there's a whole lot you can add. You could add a rule around how you name branches. But again, the best thing here is just to agree on the convention. And if you're going to add rule sets, keep it to a minimum. And as it turns out, I can't even do that here. I'm not sure why that's the case because I we we set up this org on the team account. I don't know why it's not there anymore, or the enterprise one. So unfortunately, it looks like I can't enforce the rule, but you guys can see how to do them. In fact, on a private repo, you might be able to. I thought we had the code platoon stuff set up that way, but apparently something needs to be fixed. So actually, I'm going to look into that. But you can see what that rule is. And let me just go ahead and let's go through this flow one more time. I've got the most recent version of main. I'm making my goodbye endpoint. And what I'm actually going to do is I'm just going to hop back over here to my issue. I wrote a nice little spec. I think I'm just going to copy and paste this. And I'm going to put it right here in the code in some comments so I have it as a reference as I work. And I'm going to write this code pretty quick because the code is not really the point. And because I'm feeling lazy, I'm going to do a split and use my other code that exists as a reference. And since this is an endpoint, I need to do app.root. And this is why I like the split, so I can refer to some existing code to follow a good pattern. I'm not actually, I'm a big fan of thinking when I need to, and I'm an even bigger fan of making life easier and using the computer to do the work as long as I understand what the computer's doing. And I need to return some JSON, but in Python world, it needs to be a dictionary, so I think it needs to look something like this. I think that should mostly be right. If I was doing this properly, I would test and run this code before making my pull request. Um, I can close up my split now. I'm done with what I needed. I'm going to look at the diff to make sure that the code I wrote looks good. I'm going to add the code that I want and diff it again just to make sure that I did the right thing, because something does. Oh, I'm looking at a diff of the previous commit. Yeah, I think we should be good. This is staged to be committed. Let's go ahead and commit. I'm going to make my commit message a bit richer. And in fact, I might as well just show here in my commit message itself what it returns. And that might seem like a lot of steps, but like a lot of work in adding all that stuff into the commit message. Now, when I go to make my pull request, it uses that commit message I just wrote, and it's basically done the work here for me of giving myself a nice pull request. And Owen, I'm going to lean on you again if you want to go ahead and review this. And if you want to do me a favor and maybe just like add a question on something, just so we can see it.
Absolutely. Do you want me to share my screen or no?
Uh,
Or I'll just do it right now.
yeah, I think it's fine. We already saw that full flow once. And as to the point that you were making earlier, Jacob, here again, we see that rich diff between the two different branches. And in fact, as you
Nice.
review PRs, if there's a lot of files, you can use this little viewed. You can collapse it. You can expand and collapse again. You can copy code. There's a lot of just super useful things that you can do. There's different kinds of diff views. Um, if you add little checklists, you can see them here. For instance, if I decided to add something here, checklist item, I forgot Owen that I need to do. I can preview it. I can add the comment. If I go over here to check, oh, I'm sorry. This is the GitHub Actions check. That's something different. But if I go up here to the conversation, somewhere in here, the checklists show up. I see Owen left a comment. Um, let me go ahead and look at the diff for files changed. Can you change message to message? Great call, Owen. That's much clearer. I'm gonna just go and say, will do. Thumbs up. And actually, this is perfect because we can see this is actually how a code review should work. Like maybe the team decides we want it to be message instead of just MSG. So let me hop back over here to my code, change that to message, make a commit. We'll just say rename JSON key. And now I would probably just Slack Owen and tell him it's ready for review. Depending on how good your team is at like sort of working distributedly, and if you have like email or notifications set up here, I could say, um, in fact, I can probably the GitHub UI has gotten a little complicated. There's a way to like re-request review, like Owen, and there's a way for you to use that like require changes. And so now, Owen, it's, you know, I can hit resolve, but to sort of do it the right way, the reviewer, the person requesting the change should hit the resolve conversation and give me the thumbs up that the PR is approved and good to go. And just let me know when you've gone ahead and done that. GitHub tells us this is outdated, by the way. We can see review changes. Again, if I go to files changed, see the change. If I go to commits, I can see my commit history really nicely. And this is where commit messages, again, start to become useful, right? And this is the other thing, like the smaller you make your work and your pull requests, the easier it is to review and do this. You want lots of little pull requests, not a few big ones. Awesome. Changes are approved. It's good to go. I can go ahead and merge the pull request. Juan, yes, sir.
So a lot of little pull requests. Let's say it's something big. For example, like you're making a user app or you're making whatever kind of app, like for models and all that stuff. Would you want to do just creating the user app and then push it and then do another pull request and then do the models from there and then pull requests and then so on and so forth?
Yeah, great question. Pretty much like you can, like if you think about if you're like doing a huge amount of back end work, maybe you have to make a model, maybe you have to make a view function, maybe you have to do other stuff. Um, it takes a bit of practice to figure out how to sequence things, and that's a little bit of what we'll do in the exercise. But models are a good example of something that you can usually create on their own, right? If I'm writing a new model from scratch, it probably doesn't rely on like a view class or view code or URLs PY. It might need some other existing models. It doesn't even necessarily need a serializer, but I can write a model. If we're doing tests, I can write unit tests for that model, and then I can PR that model, right? I can make a pull request just for that one thing. So depending on how big the chunk of work is, you might want to break it up that way. But it does depend on the task. Like a view function, for example, you, you don't want to slice it too fine. So in general, yes, take big things, break them down into smaller pieces, but it takes a little bit of thought and a little bit of practice to kind of see how to do that and what pieces make sense. Because The other thing about pull requests is like it should have a complete working unit of code. I don't want like half finished code or code that doesn't run, because again, the golden rule here is the main branch should always work and it should always be good. So there's a little bit of judgment in it. Um, does that help answer your question?
I believe so. I think it's like more segmenting into practical sections, I guess you could say.
Yeah, exactly. And the team exercise we're going to do does that for you, in fact, so you can kind of see it. It does a little overkill, in fact. Um, but yes, start thinking about how can I take something and break it into smaller pieces, and which of those smaller pieces are independent? Which small pieces could I merge to main and have everything run and actually work versus which small pieces would that be a little weird and confusing and depend on other things? Because the small pieces that are independent, you can break out and do on their own. The other ones, less so. Um, Let me actually just show a really simple example to that effect. And then let's take a break and then let's talk a bit about merge conflicts. So if I hop back over to our lesson content, which is hiding over here. So that we kind of looked at these best practices that I was talking about. Um, my apologies for hopping around. Um, I have a little bit on. Oh, excuse me, it's in the wrong file. So I'll talk more about merge conflicts later and what causes them. But as to your point, um, this is a really simple example of two ways to organize the same code. So, can you all read this okay, by the way? Okay, cool. I know I've been jumping around a lot. This is a really simple layout of how you might organize some of your front end code. And this, front end, there should probably be a source directory here. We're not going to worry about that. Pages, this should be a familiar organization approach to you, a different page. A services directory might not be a pattern that you've seen before, right? With API.js for that API we write that uses Axio, so I don't have to add the auth token all the time. Or maybe it interacts with a third-party API. If we have some auth code here, maybe we need some front-end form validation that goes in validators here. What we've seen more often is a utils.js, utilities.js. And this is where it's a little bit of a judgment call because the truth is, if you've got separate functions in the same file, it might not be too much of a pain point, but things tend to grow. So there are some advantages to kind of breaking up and organizing your code early on. And also, if you look at this, if I just look at this file name utils.js, it's kind of like who knows what's in there. While breaking stuff into separate files with more meaningful names helps me more easily understand what's in the code. Plus, this reduces the chances of a merge conflict, right? And so Juan, this isn't quite to your point, because it's not necessarily about breaking a bigger feature into smaller tasks, but it is another way of looking at like how can we organize our code into like smaller, more discrete units that are easier to work on. Because the name of the game really is learning how to take something big and break it into separate pieces. I think the last thing I want to show is, we talked about pull requests, we talked about code reviews. I just want to show two other examples of code review discussions and talk a little bit more about what code reviews do. So I went over this already, but the main goal of code review is human error. It's okay to make mistakes. That's normal. Good software engineering teams aren't full of superhumans. They have a good process so that inevitable human error is caught in the code review process. right? So if a bug makes it onto main, the question isn't who made the bug. The question is, how did this code get approved and merged without catching the bug? Again, quality assurance. Even places that have QA teams, devs are still expected to do QA really before merging. As a code reviewer, you should pull down and run the code. This is also where having like a team style and standards can be enforced, which makes the code easier to read or work with. As a junior engineer, you will get tons of feedback in your code reviews from other folks. Similarly, as a junior engineer, reviewing code by the more senior members of your team lets you learn from them and ask questions in the code review on that pull request. Hey, why did you do it this way? I haven't seen that before. And then finally, having design discussions like, hey, I don't like using MSG. Let's use message as our standard for this Java, for this JSON that we return because it's more readable. And just here are two examples, again, from the Django and React code bases. So this is where they actually added a model field to the Django code for Django models have a JSON field. And then we'll see one where React fragment got added. And let's just kind of look at these discussions so you all can see what I mean. So this is the actual pull request that added JSON field to Django models, which I think is kind of cool. I'm sure the code would be pretty neat to look at. You can see how much of a breakdown there is of what it's doing in the description. You can see how many people looked at this code. If you scroll somewhere, 321 comments in the conversation. There's also some automated ones, but there was a lot of discussion around this. Right. And in fact, I think this is the person who wrote the feature asking questions about it. So let me grab my annotator so it's not just hovering around. There we go. And if we go down here, we see here's someone saying, hey, I don't know if we want to do it this way. Here's an issue. What if we do it this other way? There's a ton of conversation. Someone's advising how to do this, right? So my point is, again, these are very much real world practices. And if you guys start doing this now, it also adds to the portfolio value of these pull requests. Again, here we can see adding React fragments. And we see this summary, this description. They actually use a GitHub gist to show a code example. Here's someone again giving feedback on the code, just like Owen did. Someone more senior making a decision about something, and so on and so forth. So again, I just wanted to show you guys like some real world pull requests that had a lot of design discussions and other discussions around them to show you how this happens in practice. Do folks have any questions before we take a break? Cool. How are we doing? Is this about 50% review, 50% useful? Okay,
Very useful.
awesome.
Yeah, definitely learn some things.
Awesome. Glad to hear, because I know I'm doing a lot of talking. So the agenda for the rest of the workshop is we'll take you guys want to do 10 or 15? Because I know I ran past the hour.
10 is
Okay.
fine for me.
Yeah.
10?
Some
Okay.
has objections.
Let's do 10. We'll take 10. When we come back, we'll talk about merge conflicts. More importantly, we'll see how to fix them. Then I've got basically a 30-minute hands-on team exercise for you guys. And then I have like one more lecture going over teamwork tips that sort of just summarizes everything and it's sort of the culminating thing. And I'm on a different time zone at the moment, so let me just make sure I'm tracking on time. It's 11:40 right now? Do I have that right?
Well, 11:27 right now, Central Time.
11:27.
Yes, I believe
Okay,
so.
perfect. All right. Then actually what we'll do is we'll take 10, we'll do the merge conflict stuff. I'll give the final lecture, which is quite short, but it's going to be useful. And then that way you guys can break for lunch and either during or shortly after lunch do the team exercise. Um, does that sound good to folks? Awesome. Okay. Thank you, everyone, and I'll see you all in 10 minutes. And let me go ahead and share my screen from after our break, and we can continue on. I totally was using Claude here for some help. So here's what we're gonna do. And Owen, I'm gonna ask you for some help again. Um, and just to kind of recap where we're at as well with stuff. Um, oh, did I make these? I made these issues on the wrong repo. I'm so sorry, guys. I made them on our actual Git workshop. So give me. Oh no, this is the right one. Nope, this is the wrong one. Let me go ahead and move these. My apologies. Just bear with me here. And as I'm doing this, let me just explain what we're going to do. Basically, I've made two issues. Owen, I'm going to give one to you. I'm going to take the other. These issues are going to cause a conflict. And then I'll show on my branch how to resolve that merge conflict. And then once we've done that, um, I'll talk through sort of what causes merge conflicts, how to avoid them, and good team practices in general. So, um, Owen, this one is going to be your task, and I've gone ahead and I've put the code in there that I think should do it. I totally used Claude AI to help me write this code, but we're going to have our goodbye endpoint accept the query param so that we can say a goodbye message to a student. So here's the Flask code that should do it. I think this is all you need to do to grab a query param in that goodbye endpoint. And I think this is the code that will grab a student with that ID from our Python list of all students. Um, so I want you to do that. I want you to then make the goodbye message, say the student's name or something. But I want you to, because these are what's gonna help cause the merge conflicts. Because I wanted to see a number of changes so that when we look at the merge conflict, it's not just about fixing conflicts, but also seeing what code of Owens do I need to make sure to keep, what bits might I need to change. Rename all students to something else, and you'll need to do that in here, and give each student a different name. Um, does that make sense and sound feasible, Owen?
Yes, I just need some help on the actual file. And also, do you want me to check out to another branch before I do
Yeah,
this?
absolutely. Check out to another branch. Um, go ahead and get started. What I'll do is you can just work on that, and I'll work on my task. And then when I'm done, I'll check in with you, and we can always screen share and pair to wrap it up. Sound good?
Mhm. So I've
Okay.
checked out. Now I do what? Get pull.
Yeah, yeah. Actually, why don't we just pair on doing this together?
Okay, I'll share my screen.
Perfect.
I
I think that'll
apologize
actually
if
be
there's
great
a
for
bunch of
everyone to see.
background noise. My dog is chewing on a light bone.
I don't hear anything for what it's worth.
Okay. So I have checked out to my feature branch. I've pulled, and now I should get push.
Uh, yeah, if you have to, I have my Git repo set up where I don't even have to do that.
Okay.
There's not going to be anything that there's not going to be any code on here, so there's nothing to push yet, so it doesn't matter that much.
Okay.
Um,
I just want to make sure that is.
yeah, no, I think you're good because as long as you're doing it on a separate branch, we'll have the pull request to look at the diff.
No, I have that code that you put in the issue copied to my clipboard. Where do you want me to put that?
Um, and give me one sec to make sure that I have main. Okay, perfect. Um, so head over to is there a goodbye endpoint? Yep, on line 45.
Okay.
just go ahead and put that code like right inside the goodbye endpoint, below the function definition, actually inside def goodbye.
Okay.
Yep. And you'll probably need to get rid of that empty line if because I think that decorator needs to be right on the line above goodbye for how
Yeah.
Flask works. Yeah, I know we haven't done a ton with Flask, but I figure it's easier. It looks like I probably did miss a line of code here. That goodbye function, we probably need to give it an argument request inside those parentheses. And I'm going to break my own rule here. We're not going to worry too much about if this code works, just if it looks right enough.
Mhm.
So that's about it. So now you've got the ID. Now you've got the student. I'd like you to just change the message to say goodbye in that student's name by using like an F string there.
Okay. Oh, okay.
Yeah. And then we'll do the other changes too. And I'll talk to later about why the issue I created was a bad issue because it has too much in it. But that was sort of on purpose. Um so yeah, you don't want to make, let's do this. We don't want the F string on message. My apologies, because we still
Okay.
want to return, we need that dictionary there where the key is message and the value is the message itself.
Do you
Yeah,
need me to
so
do
why don't you just
dictionary
put,
right here?
yeah, let's do this. Get rid of that little dictionary. Below line 48, below student, let's just create a new variable just named message and just set it equal to an F string. And let's say, goodbye, the student's name in there.
Where is student? What would it be? Yes, student.
And then it's going to be like bracket. Yeah, exactly. Exactly. You're going to put message there. And I would do inside that brackets on the where we're creating the string message, just do like student dot get name or student bracket name or whatever.
Right here.
Yeah. And you're gonna need the single quotes if because we're grabbing a dictionary key bracket style, right? Yeah, I know. The switch to Python and JavaScript can be a bit wonky.
Alrighty.
So, right. So this touches on something else actually, but I've got the teaching hat on, so I'm gonna run with it. As you guys are discovering, the skill set to like write a real full stack project is different from the skill set to do like lead code problems and like technical interview problems. Because you guys will find that at the end of the group project, you're going to kick ass when it comes to writing code and building a project, but be a bit rusty on some of these sort of like nitty gritty things because you don't do them as much. So after graduation, you all are going to want to do a bit of grinding on leak code and stuff like that. Um, so this looks great. We're also going to do some other things. Let's change all students. Let's change that variable name to something else, but let's, change it for all of them. Yeah. Um, and actually go ahead and yeah, leave all students there for me. Scroll up a bit. Just right click on that very first all students. Oh, you've got the multi cursor. Perfect. Yeah, however you want it. I was just going to say use VS Code to change it everywhere for you. Don't do it manually. And I was going to walk you through that if you want. Let me walk you through it. Why don't you oh no, you've got it. Yeah, just change it to whatever you want. Something else. Change it to something else. We can change it to students. Perfect. Okay. And lastly, go ahead and change the names of all the students up in those lines of code. Yeah, change Harry, Hermione, all those to some other names. And while you're doing this, let me talk about the problems with the scenario I gave you. First off, we're changing data and we're changing logic as part of the same pull request and the same work. That's a bad idea. We want to separate those things. They should really be separate issues. Second of all, while it might be a great idea to change the name all students to students, we shouldn't do it as part of the same task where we're adding a feature to the get endpoint because it increases the risk of merge conflicts. It makes it harder to review the code. Third of all, ideally, we would do each of these as a separate commit because if each of these changes is a separate commit, it makes it easier for Git to add them and integrate them with other changes and avoid conflicts. So on purpose, we're kind of doing this the worst way possible. We've got a number of disparate changes on one commit on one pull request. And then when you're done, just go ahead and add and commit all that code and push it up and make a pull request. And I would say just go ahead and merge your own pull request, and we can just walk through that flow on your machine if that works for you.
And then pull request or push first?
Well, if we don't push the code up, there's no code. That code isn't up on the Git repo on GitHub in the cloud, right? So we could make a pull request, but there would be nothing there because the branch on GitHub doesn't have any of this code. Does that make sense?
Yes.
Yeah. And that's part of why we're doing this workshop too, is just to kind of review these parts of Git that we haven't been using as much.
All right. And then that's pushed now.
Perfect. If it's pushed, why don't you just go are you able to go to the browser and we can look at the pull request?
Yes.
Yeah, I would just hit compare and pull request. Yeah, that's the easiest way to do it, to be totally honest. And why don't you make sure to add the issue number in there? It's like #3, or it's going to be 3 or 4. I would put it in the message because if you GitHub gives you a really nice autocomplete, if in not the title but the message, you hit the pound symbol. Yeah, you can. It's not the worst idea, to be honest, to put the number and maybe a description in the title, but the link in the message is kind of the key thing, and GitHub makes that real easy for you.
All good?
Looks good.
All right. There's no
Awesome.
conflict.
So we can ignore that warning. Why don't you look at files changed? Let's look at the diff.
Go back to.
Nope. Sorry for the confusion. Go back to the scroll up a bit. So you see those 4 tabs: conversation, commits, checks, files changed. Yeah. And actually, everyone, this is important. Every single time I make a pull request, this is the first thing I do, is I look at the diff to make sure that it has what I want it to have and not what I don't. So it looks like by default, you have a different way of viewing the diff set up on GitHub. This is a combined view. I kind of like the split view, but let me show you how to change it so that you guys can use the one you prefer. It's exactly, thank you, that little gear button, and go ahead and do split. I find the split a little easier, but it's really up to you guys, whichever one. So does this look right, Owen? Are we seeing only the changes that you made that you want to have here and not anything else?
Yes.
Awesome. Let's break the rules for the moment and go ahead and just merge your pull request.
Ooh, it's not going to let me, I don't think. Or wait,
Oh,
I'll just have to go back.
yes, the UI is a little weird. They've added an awful lot to it. Um, Again, I really, really encourage you all to just get in the habit of doing actual code reviews. Because if you don't force the habit, it's too easy to break it. But for the purposes of time, we're not going to do it. Great job, man. I know I kind of put you on the spot, so thank you. And let
Mhm.
me take over the screen share.
Okay.
Awesome. So Owen's done that work, right? And it's over on the main branch here. If we look at the commit history for main, we see Owen's work. I have not pulled that down onto my local repo yet on purpose, right? To kind of go back to our diagram. Owen's work is over here. I have not pulled it down yet. It's not over here. So the scenario that we're about to play out is what's going to be really normal of Owen and I working in parallel, right? So just pretend that at the same time Owen was working on that, I've been working on a separate feature. And my feature is, let me go ahead and create it because I made it in the wrong one. Move all students, move the all students dictionary into a separate file. And in the interest of time, I'm not going to add a description here. But the goal of this is to organize our code better because it's kind of nice to have your data separate from your logic. Maybe we need this in other parts of our code. Maybe this is in fact fake data or stub data or mock data, so to speak. Mock data is really the term that we're using, and eventually it's going to be replaced by actually getting the data from the database, right? And moving this dictionary out of moving this list of students rather out of my main application logic is a step in that direction. So Owen and I are working on our two features in parallel, which means that when I started work on this, I don't have the code that Owen just wrote. My main branch on my local machine is behind. I'm going to check out a branch. I'm going to have it start with the issue number. And just give it a name. And I'm going to keep this really simple. I'm going to go into this backend directory right where there's app.py. I'm going to make a file named allstudents.py. Owen and I are working in parallel. I haven't really, I was not aware that he's renaming all this stuff. So my task is relatively simple, though, in fact, it's a bit more complicated because I totally forgot about this student class. And this happens too when writing code. So I'm going to make a judgment call here that really this student class doesn't belong in app.py either. It in fact belongs in a separate file. So I'm going to make a file named student.py. And I'm going to put this here. And get rid of it from here. And over here, I'm going to need to import it. And I can use it here. And now in app.py, I'm going to get rid of all students here. And just right up here, along with all my other imports, import my list of dictionaries. And just to kind of review what I did, we've got at PY, we've got the student data, we've got the student class, right? So you can kind of see again how the file organization and it starts to become useful, but also it's important to kind of set up conventions as a team on how we want to do this and name stuff early on. And so I've got this class here. I import it here to create this data that eventually will come from the database. And then I have it in my main application logic. And I'm feeling pretty good about myself. Now, really, this should be three separate commits. And really, I probably should not have done this as a part of this feature. If this is a big project, if this is real code, or even just, 4 days into the group project, 6 other people might be depending on this and moving this somewhere else. It might break things. So it's useful to have that as a separate unit of work on its own branch and with its own pull request so people can review and to avoid merge conflicts. So I'm doing some things wrong here as well. I also really should have these be separate commits for the same reason. I'm not going to do any of that. I'm going to make a nice commit message that's going to save me work on the pull request. Going to explain why. All students will eventually come from the database. And I'm going to go ahead and push my code. The branch isn't created on GitHub yet, so I got to create the branch on GitHub, push my code up, right? To go back to our diagram, I've just done this step. And now I'm going to make a pull request. And let's watch what happens. I'm going to go ahead and compare and pull request. Note, can't automatically merge. I'm already getting a heads up that's a merge conflict. That's fine. I'm going to make the pull request anyway. I'm just going to add the issue number here. By the way, if you ever want to create a pull request just for the purposes of comparing this, I think if you have your own repo on your own GitHub org, it'll let you do a draft pull request. We need to be on a different pricing tier. A draft pull request cannot actually be merged, so it's sort of a safer option. So let's see what's happened now that I've made this pull request. This branch has conflicts that must be resolved. So the first rule of resolving merge conflicts is never do it on GitHub. Never, ever, ever resolve a conflict on GitHub. Right? Conflicts don't get resolved here in the cloud. They get resolved here on my local machine. The second rule of resolving conflicts is always do it on the feature branch. Not here, here, right? Not there in the cloud, here. 2 reasons for doing this. We want to protect main. If I screw something up while fixing the merge conflict, I want to screw up my feature branch, not the main branch. The reason to do it locally is because it's way easier. VS Code has a much better diff tool. Sometimes you have to make more changes to code when resolving a conflict. Yes, GitHub has a web editor you can use. I'll show you what it looks like, and just so we don't use it, let me get rid of my annotation. My apologies, I can't figure. There we. I can't figure out how to get rid of my annotation, so I will just maybe have it lurk up there for the moment. So you don't want to use this. It kind of sucks. And it's just going to make life harder. But let's look at the diff. So the diff is useful Um, though I would have expected to see. Yeah, the diff doesn't quite. We have to expand some stuff here. And oh, and yeah, your code got merged. So I'm not sure why the diff isn't showing me the conflicts here. I kind of would expected to see that. We're going to be able to see it on VS Code in just a moment. I'm curious if this does it show up in the unified view? And I'm just going to double check that indeed, oh, and your code is on main. It could be GitHub just being a little slow. Um, it's either GitHub being slow or I jumped to the wrong conclusion about the diff on the GitHub code editor. I feel like I should be able to see the changes there, but we're going to see them on VS Code. Um, yeah, it doesn't show the changes as well as I would want, but the key thing really is this right here, where it says conflicts and that these conflicts must be resolved. So here's how you resolve a merge conflict. I'm going to go to VS Code and I'm going to resolve it here. And if you want to, before doing this, you can make a backup branch. So step one, I'm going to go to the main branch. I'm going to pull down the most recent main, right? I have to get Owen's code that's on GitHub onto my machine because my main branch is behind. And now I've got Owen's code here where he changes the names, he does all the work. If I go to app py, we can see all the work that Owen did, the new names, love it. Students, the goodbye message. Note that these files don't exist on the main branch. My next step is similar. It's the same flow. I'm going to merge main onto my feature branch, right? Just to say that one more time, I'm going to merge main onto my feature branch. So I need to hop back over to my feature branch because I want to protect main even on my local machine. And also because I need my feature branch to be good before we can merge it. Because the goal is right now up here in the cloud. Let me add something to TL draw. Let's have it be like there we go. Perfect. And it is going to be red. Right now, my branch is bad because there's a merge conflict. And specifically, the code, the commits for my branch up on GitHub are bad, right? This is the conflict that I need to resolve. So the way I do it is I pull main onto my feature branch and resolve the conflict here, and then push up my fixed feature branch so that what we end up with is the feature branch being good, right? With green for ready to go and ready to merge. So I need to cause the conflict here, fix it, push that fix up, and then we can merge. Does that make sense? And do folks have any questions? Okay, and I realize that I'm going past lunchtime. So let me just check in. How are people doing? We doing all right? Okay. I know I've been doing a lot of talking. This is sort of our final step. I have a little bit more talking to do, but it's going to be a lot quicker, and then we can break for lunch. And I've got an exercise for you guys to do afterwards that is really more hands-off that you guys will be able to do after lunch and tackle independently. So let's fix this merge conflict. So I'm going to go back to my feature branch. I'm going to do git merge main. And we see a couple things happen. First off, on the command line, we have this message that there's a conflict. Second off, we see this resolve and merge editor button, which we're going to click in just a moment. Third, we see all this stuff in blue. And these sort of options, accept current change, incoming change, so on and so forth. You can resolve the merge conflict here. I recommend using the merge editor because you'll need to become comfortable with it, because as you progress in your career, you will encounter merge conflicts that require a bit more work. Though at the end of the day, it's personal preference. But at minimum, knowing how to read the merge editor is important. Before we do that, let's look at the code. So I know there's a lot of color and a lot of UI that's been added here. Let's distinguish between what's UI and what's actual changes to code. Accept current change, blah, 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 blah. That's the GitHub UI, right? So are these colors. But this right here, that's actual text. Right? And so is that line below it. And the reason I want to point this out is because this is how Git, not GitHub, not VS Code, but Git represents a merge conflict. It has actually modified our code. And we see up here, head is the branch I'm currently on, which is my feature branch. Main is the incoming branch I'm trying to merge onto my feature branch. And so we see here, and it's a little confusing to view this way, which is why we'll use the merge editor, the code from main. But I want to point out that a merge conflict is Git adding this stuff. And if I just deleted all this text that Git added, like if I went ahead and I deleted this and deleted that, as far as Git knows, the merge conflict is resolved. The code will probably break, but Git doesn't know anything about our code. Git has just seen this issue with commits and it's added this text to it. And that's how it and VS Code identify merge conflicts. And I just want to check in and see if folks have any questions around there, because you're not going to have to mess with the text, but it's really important to just get that basic concept. Does that make sense to everyone? And do folks have any questions? Okay, awesome. The good news is no programmer ever actually modifies this directly. Pretty much as soon as Git was invented, diff tools and merge editor tools were invented as well to deal with this. But I just want to show you how Git tracks this stuff because it's good to see. And if I scroll through the code, probably my other files, there's stuff, but let's go ahead and hit resolve and merge editor. Let's see if I can make this a bit. Does it do a Zen mode? Can you all read this okay? There's a lot of stuff in here. This is a bit confusing. Let me walk through what this is. The center, this is the result. This is the outcome. This is like the actual code. On the left, we see the code from the incoming branch from main. This is the code from main on the left, right? On the right, we see my current feature branch code. And when we're done, the stuff in the center is going to be what's on my feature branch because I'm on my branch now, but we're merging stuff, either from the left or the right, either from my feature branch or main into the center. And it stays here on the feature branch, but these are the two different possible versions we can draw from. Is there anything that people are maybe curious about with with that, and everyone feel good about that basic layout. Cool. The diff tools, it takes a little while to get used to it. It definitely was not intuitive for me to read when I started doing this. I've been doing this for years. The VS Code one is pretty good. And you can actually edit the code. Well, you can't edit that one because it's read-only. And you can't edit that one because it's read-only. But this one in the middle is our actual code, and we can actually edit stuff. And we, in fact, may need to. So, as you can see, it's all about choosing which changes you want. In general, you don't want to manually edit stuff. You have to, but you want to start by using the options. I can accept my version, or I can accept Owen's version. And down here, by the way, Owen changed this goodbye endpoint a ton, right? If you guys recall, like my code does not have the ID. It doesn't have the fancy goodbye message. But there's no conflict here because this was easy for Git to resolve because there were not two conflicting versions of the same thing. Git could clearly tell this stuff should be added, and there's not like the same line of code that gets modified. Here, the problem is Owen made a bunch of changes to these lines of code, and I did too. My change was to delete them altogether, but if I'd done something else, we would run into the same conflict. So I wanted to do this to demonstrate how in a merge conflict, there's some code that Git can figure out for you just fine and merge it in. There's some changes where you are going to have to do some thinking. Because on the one hand, I can accept Owen's changes, and that's fine. But if I scroll up here, I've got from all students, import all students. Then over here, I'm using students, right? And I'm doing this. So this sort of totally defeats the purposes of what I wanted to do. So I have to actually do a little bit of thinking here. I'm going to leave this merge editor window open. I think I'm going to exit sort of the Zen mode because we need to think about the other files in play. I have all students.py. I have student.py. How am I going to get these other changes that I wanted and fix the merge conflict? And the answer is I have to do it in steps. And I think the easiest way is let's resolve the merge conflict and have Owen's code be here. I'm going to have to do more work, but let's start with that. But now I need to do some more work because I don't want students here. I want it in this all students file. But these names, because there's all students and student, so I need to rename my all students file to maybe something like student data. And if I type git status, I now see that it's up to date. All conflicts are fixed, but I'm still merging. I can keep doing work and adding it to this merge commit. And in fact, I'm going to. And I'm in fact going to use the git move command. So the same way you can move or rename a file on the command line, Git has a version of that that will tell Git I'm moving a file. Because if I just plain old move it, Git will think of it as being deleted and recreated. So let's move all students into student data py. And now Git knows that this file was renamed. If I just did plain MV, it would show like deleted and new file. There's also git rm to delete files, and those can be very useful commands, though this would work without them. So that's a good step right there, right? And in fact, if I was doing this for real, I would actually do this maybe in a series of multiple commits for safety. but it's good to see how to resolve it all in one. So I've taken care of that. So now student PY should be fine. It still gets imported into student data just fine. But I want to make the same name change that Owen did. And I'm just going to go here and rename symbol to student. Actually, I'm not going to do that because Owen also renamed all these names. I will show that just for fun because this is a good tool to know how to use, right? That's the safe way or the multiple cursor approach that Owen did to rename something in a bunch of places, not to do it manually. And of course, there's a keyboard shortcut for it. But because Owen renamed all these, what I'm just going to do is I'm just going to copy all this code. I'm going to cut it out of here. I'm going to put it in here and just delete my stuff. So now, again, I'm trying to minimize the number of edits I make to the code to minimize the kinds of mistakes I might make that might cause more merge conflicts or actual bugs in the code. And so resolving the merge conflicts, the diff tool is only half the battle because I actually have to think through and understand what's going on with the code. And this is why it's so important not to mess with other people's branches and communicate about this stuff. And in fact, really what I need to do is I might need to ask Owen for help when I'm doing this so I can understand his work, or at a very minimum, when I pull request this, I have to tag Owen on this, right? Because who knows the right version of the code that Owen wrote for that feature? Owen, right? Because you guys know how complex Django stuff is. Like you can't just look at someone else's code if it's a non-trivial bit of work and know if it's 100% correct or not. It's like, no, we got to go to the source. We got to go to the expert. So so this is where again that communication and collaboration is really key. So if this is a really tricky merge conflict, I might actually ask Owen for help. But at minimum, like Owen, I'd be tagging you as a reviewer on the PR and saying, hey, I had to deal with a merge conflict. Can you look at this to make sure that your work is correct and I didn't accidentally change anything that shouldn't be changed? Does that make sense to folks? And is everyone kind of tracking? They know I've been doing a lot of talking here. Um, as you can see, like it also pays to go slow when resolving merge conflicts. And most of all, it pays to avoid them altogether. And that's what I'm going to talk about in a minute. Because that's really the other golden rule of merge conflicts is the best way to resolve a merge conflict is not to have it in the first place. So hopefully you guys, do you feel like you're starting to see how Owen and I could have done this work differently to avoid some of these conflicts? Maybe. Well, let's recap. Well, I'll push this up and then we'll recap because I'm pretty much done, I think, making my changes. If I go to app py, the last change I need to make here is from student data, import students. So this is also why running your code to manually test it if we don't have an automated test suite is so important before making a pull request, and why it's so important to do it as a code reviewer. Because this step I just did here, this is the most dangerous thing because I'm not using the merge tools to, with this merge conflict, like this is where it's really easy to make a mistake. So now if I type git status, we see a bunch of changes. And let's do git add dot, and let's do git commit. And now it pays for me to write a bigger merge conflict message here. Merge conflict fix and feature add. And I'm going to write out again what I did. right? Just to really make sure I'm not missing anything important. And now if I do git status, I should be good. I'm ahead by a number of commits. I push to go back to our diagram, right? I fixed the merge conflict on my feature branch on my local machine, and I just pushed that up to GitHub. Now let's go back to this pull request and see what it says. The merge conflict is gone. This is where getting the review, and normally, Owen, I would tag you and be like, hey, please look this over, is really important. This is where having someone else, a second set of eyes, is important. And this is where running the code to make sure it works is really important, because we made a ton of changes here from a number of things. And if I look over this, this looks good, right? And now I can go ahead and merge this pull request. And delete the branch. So let's talk about how we could have avoided this. First of all, look at this issue that I created for Owen. It has 3 completely different things in it. Adding this feature to the goodbye endpoint, that's its own issue. That'd be cool. That would work fine. Renaming this dictionary, that has nothing to do with that feature. That should be a separate issue, a separate branch, a separate PR, a separate commit. We would have avoided the merge conflict. Renaming the students, also separate. We would have avoided the merge conflict, right? So that's a really good example of things to look for as you chunk up work to avoid merge conflicts. And to sort of go through some of this stuff and recap, this might be useful to read over. I don't want to go into it too much now, but there's 2 different ways that Git merges stuff. The kind that causes us problems is this one, called the 3-way merge, where commits happen on the main branch while someone else is doing feature work because, say, some other feature has been merged. But in terms of avoiding merge conflicts, same line changes cause merge conflicts. Avoid uppercase directory names. On Linux, the file system's case sensitive. On Mac, it's not. It will cause a nightmare. Structural changes, renaming files, that was an issue for me. So these are some things that you can kind of keep in mind. But to kind of sum this up, because I'll walk you guys through the exercise, but and how are we doing? Okay, because I realize I've been running way long here, and it's now almost like 1 o'clock. Are we good for about 5 more minutes? Okay,
Yeah.
thank you, and thank you for being patient with me. To sum this up, these are not novel problems. This feature branch workflow and kind of working in this way has been kind of done for at least a decade, probably since the early 2000s. So, and this is all on a page in that workshop repo as well, condensed for your team to follow as well. I put together basically a list of tactics, and they all kind of work together. And I think if you guys as a team implement each of these, you'll find you have much smoother sailing. So there's a list of all 10. I'm just going to walk through each one. And again, they're also listed on that curriculum repo that we were looking at. That's the workshop repo. So you can see it there as well, which is maybe an easier place than the slide deck. This one, I think we all are getting the handle of. 2 people should never touch the same code at the same time. You should never touch another person's feature branch without permission. Always keep the main branch in a good state. this is going to require some work, but it will avoid so many problems and pain points. Just always keep main working. Don't break main. And so it's okay if it takes longer to update to main. You could even create a dev branch where PRs get merged and merge dev to main, but keep main in a good state. Do a daily stand up. Um, we've been doing stand-ups and stand-downs because we're a class and it's a classroom. It's a little different than like what how they work on an engineering team. For group projects, this is what your guys' stand-up should be like. It should be quick. If it's 10 minutes, that's probably too long because your teams are small. Um, you cover three things. This is what I did. This is what I'm working on. These are my blockers, problems, or questions. You don't talk about the questions. You don't talk about the blockers. You talk about that after the stand up. And so in the stand up, Owen would say, today I'm working on changing the goodbye endpoint and I'm going to rename all students. And then I would say, today I'm working on moving the all students list into a separate file. And then I would say, Owen, maybe you and I should chat after the stand up so we can coordinate. Because that's the other way to avoid merge conflicts is spot them before they hit you. And if you do a actual focus stand up like this, it will help with that. Break work into small chunks. You're going to see how to do this with the team exercise. Hopefully, you're starting to see the hang of this. Think small. Like you could have an issue and you might be able to break it into 2 or 3 smaller ones. You can have them all be on the same feature branch. You can make multiple pull requests off of the same branch. The smaller the pull request, the easier for someone else to review, to test, to QA. The more often you merge stuff to main, it reduces the risk of conflicts. If I'm working for like 2 days, I have like 20 new files and 500 lines of code, that's gonna be a nightmare for everyone else on my team when I make that pull request, when they merge that onto their feature branches. So this will help you as a team and individually keep velocity and momentum. Similarly, um, as you're working, you should merge main onto your feature branch daily. Like, whenever someone pushes something, you might need to check. Sometimes you might need to be strategic to avoid a merge conflict so you can focus on getting your work done and deal with it later. But if you're proactive about this, it's easy to fix. And also, I think you guys saw, you know, I had a bunch of different things to tackle in that merge conflict. There were like 3 different things. But if there was only one, it would have been way easier. So tiny merge conflicts are easy. Medium-sized merge conflicts are hard. Merge main to your feature branch a lot so you have tiny merge conflicts. Do code reviews for everything, right? If you do all work off of feature branches and with pull requests, and you always have at least one other person reviewing code, this forces you guys to share knowledge. It forces you guys to be aware of what other people are doing, which helps avoid merge conflicts, and it forces quality assurance. So, as many of you experienced on the assessments, you work for a whole day and you write 500 lines of code, but then you have 20 bugs, right? And really, we want to avoid that. Identify work that can be done in parallel. I think I've kind of covered this. Look for points when work can conflict. Use the stand up. Use planning meetings, which I'll talk about in a second. Look ahead a bit. This can help avoid this. This one is super important. Let me just say that again. This one is super important. Fake it. Use fake data. You're doing front end code, fake the API calls so you don't have to wait for someone to write the back end endpoints. Or if you need to, ask them or go ahead and yourself write a back end endpoint that just returns fake data. Or if you're writing a back end endpoint but a model doesn't exist yet, fake the model. You can fake so much stuff and it helps you move forward. Mock data is just another term for fake data. Stub is a term for code that doesn't really, it works so that other code can work, but it doesn't actually do what it's meant to do yet. Um, I think agile sprints have value. It gives you some flexibility. The idea of a sprint is the team plans what they want to work on. Normally they're 2 weeks. I think for you guys, 4 days is a good amount of time. You kind of decide who's going to work on what. You decide what the priorities are for the sprint, decide what the priorities are for your next 4 days, and you think about realistically how much will each of these take. Just remember to take an estimate and multiply it by three, so you don't overload, and then you don't add in anything new. And this is sort of a team commitment. So if I get done early, I help my teammates. The advantage of this is at the end of it, you can review and assess and see what worked well. You can adjust. If you guys are behind schedule, you decide maybe we need to cut a feature. If you're ahead of schedule, you can bring one in. Not everyone's going to like this, but it might be worth trying pair programming. Um, it actually can make it easier to continue work if one person has, VA appointments or New Year's travel or gets sick. Having two people pair on an important feature means, if I'm going on vacation for 2 days around New Year's, I can maybe get started with Jacob, but then when I go, Jacob can finish that important backend feature. It also can help with accountability. It also, frankly, helps you, like, you'll design the code better. Not everyone loves this though, so you can't really force it. If you're interested, do it, but you can't force it. Finally, you gotta choose a manager and you gotta choose a leader. Like each project kind of already has a leader because it's the person whose idea the project was, who pitched it, right? That's the person who, in a lot of ways, has the vision, right? Who can say, all right, this is what I think we should focus on. This is what it should be, set some goals, and also kind of helps motivate the team. The manager is thinking about schedules, timelines, who's going to keep the Trello board up to date, who's going to make sure that that pull request gets a reviewer. Um, Sometimes one person does both, sometimes not. Both approaches can work equally well. And to be frank, it's better to have no manager than to have a bad manager. So pick someone who wants to and has the right kind of skill set to manage, because there's got to be someone. But what you don't want is a manager that doesn't want to manage or who's not good at communicating. And finally, for those of you who are kind of filling these leader manager roles, do it with a light touch, talk less, listen more. Your goal is really to help the team work as a team. Software engineers have a lot of autonomy and ownership, and that's how you all will be able to be most productive. These aren't new tactics, they've been around for a long time. And I'm speaking from experience here, having worked at a number of startups and seen these done well and done poorly. Um, when you do them right, they can help with flow. They give some accountability and structure without getting rid of like ownership and freedom. So I think they can really help your team. And then this you can put on your resume, hey, we did like agile development for our group project. I did code reviews. I had my code reviewed. We did stand-ups. We, did sprint planning. You can already say that because we did it in the class, but you can say it even more so for your group project. So that was really the last thing I wanted to cover. Those same tactics are listed here with a bit more detail. Again, in that repo that has the workshop curriculum. And let me send it to you guys in Zoom now. I'll put it in the Slack channel, but if someone can repost it, I'd appreciate it. Let me show you guys the assignment. And thank you so much for bearing with me because I know today was sort of like a mega marathon. And let me actually I'm just going to do it now. Um, because I want to make sure that the link gets there. So let me just dump them in. So the assignment. You guys are going to build a full stack React Django Pokédex, but I've written the code for you. What you guys should do is get lunch, get off the screen, then as a team, set a timer and do this in 30 minutes. And you probably can, because most in previous cohorts, people did this pretty quickly. Clone the repo, make sure everyone has access to the repo. Then, if you check it out here, a lot of the backend code is already written. Did someone push to this? No. Yeah, this is what it should be. Some of this code is written, but a lot is not. There's backend code, there's front end code, but then there's assignments. Like Pokemon moves. One person on the team will do this. And I've written the code for the Pokemon serializer for the move. But you got to make a feature branch and make a pull request and have someone else review it and merge it. Another person on the team is going to write the front end code for a Pokemon move. Same deal. Another person is going to have to update the Pokemon model. So I've sliced this really fine, right? I've sliced it a lot finer than you would do in the real world so that you all are going to be forced to communicate. One person is going to just make the URL's PY code for this. So it's either going to take you 30 minutes with no sweat, or it might take 45 minutes. None of this will actually cause a merge conflict, but if you guys don't sequence it right and coordinate it through sort of inevitable error and confusion, merge conflicts might occur. So again, make sure the code runs, and I would really think about try to practice all those teamwork tactics that I just walked through on here. And this is maybe a bit more finely sliced than it would be in practice, but it will give you a really good sense of how to chunk up work, right? So that's the workshop exercise. I've gotten really good feedback on this. I think it should be both smooth sailing and useful. I wanted to do a discussion at the end of it, to kind of, as a class, talked about what we learned, but on a practical level, considering how long this morning part ran, and that you guys can have that conversation on your own, and I've eaten into a lot of your day, I think the easiest thing is for you guys to tackle it independently and discuss. Do folks have any questions around that assignment? Make sense? Okay, awesome. Again, the code is all there for you, so it's 100% about practicing the feature branch workflow. All right, folks, I really appreciate you guys being flexible today. Um, I know it's been long, so thank you, and I hope this was useful. Let's break for lunch because it's been a long day. Do this exercise. Just talk amongst yourselves as a team. Set the time you want to reconvene and do it, but please do it. It's not going to take you that long, and I can guarantee you it's going to be useful. And otherwise, it's a group project work day. And this sort of wraps up that second Git workshop. So thank you all very much. I'll have the video up shortly. Have a good lunch, everyone, and I can stick around a bit to help answer questions from anyone who has them. And actually, Gary, I think I'm going to give you the Zoom co-host. So thank you, folks. Have a great lunch, and I'll stick around a bit to answer questions for anything that might be on people's minds. And let me go ahead and open up the breakout rooms as well. Hey, Jacob. Hey, James. How's it going?
Good. Did you need to stop the recording?